Pile integrity testing, or PIT, is a non-destructive method used to evaluate the structural integrity of foundation piles. These piles are crucial components of a building's foundation, transferring loads from the structure to the ground. PIT helps ensure these piles are sound and free from defects that could compromise the entire structure's stability. It's commonly used in various construction projects, from bridges and high-rise buildings to retaining walls and other structures requiring deep foundations. By assessing the condition of piles, engineers can make informed decisions regarding the safety and longevity of the structure. Early detection of pile defects is crucial. These defects can occur during the pile installation process or over time due to environmental factors. Ignoring these issues can lead to costly repairs or even catastrophic failures. In essence, PIT acts as a health check for foundation piles, providing valuable information about their condition and helping ensure the long-term safety and reliability of the structure they support. Conducting a pile integrity test requires specialized tools and equipment to generate and measure the stress waves traveling through the pile. These tools work in tandem to provide a comprehensive understanding of the pile's internal condition. The primary tool is a hammer, which delivers a controlled impact to the pile head. The hammer's size and impact energy are carefully selected based on the pile's dimensions and material properties. This impact generates stress waves that travel down the pile's length. An accelerometer, securely attached to the pile head, acts as the sensing element. It measures the acceleration of the pile head in response to the hammer impact. The accelerometer converts these vibrations into electrical signals for further analysis. A data acquisition system is used to capture and record the electrical signals from the accelerometer. This system digitizes the analog signals, allowing for storage and subsequent analysis using specialized software. The software processes the recorded data to generate graphical representations of the stress wave propagation within the pile. These graphs help identify any anomalies or reflections indicating potential defects. Before conducting a pile integrity test, careful preparation is essential to ensure accurate and reliable results. This includes preparing both the pile head and the testing equipment. The pile head needs to be properly prepared to ensure a good impact surface for the hammer. Any loose concrete or debris should be removed, and the surface should be relatively smooth and level. In some cases, a steel plate might be placed on the pile head to provide a more uniform impact surface. The accelerometer needs to be securely attached to the pile head using a strong adhesive or a magnetic mount. Proper mounting ensures that the accelerometer accurately captures the pile's response to the hammer impact. Prior to testing, it's crucial to calibrate the entire system, including the hammer, accelerometer, and data acquisition system. Calibration ensures that all components are functioning correctly and providing accurate measurements. Safety is paramount during the entire process. The testing area should be cordoned off to prevent unauthorized personnel from entering. Personnel involved in the testing should wear appropriate safety gear, including helmets, safety glasses, and steel-toed boots. Conducting a pile integrity test involves a systematic procedure to ensure accurate data collection and reliable results. The following steps outline the typical process. First, position the hammer directly over the center of the prepared pile head. The height and angle of the hammer are adjusted to deliver the desired impact energy. Next, release the hammer to impact the pile head, generating stress waves that travel down the pile's length. The accelerometer, securely attached to the pile head, captures the pile's response to the hammer impact. The data acquisition system records the electrical signals from the accelerometer. Repeat these steps multiple times, typically at different locations around the pile head. This helps to gather a comprehensive data set and account for any variations in the pile's response. Once all the impacts are complete, transfer the data recorded by the data acquisition system to a computer for analysis. The impact process is usually very quick, often taking less than a second. However, the setup and data analysis can take longer depending on the complexity of the pile and the software used. Section 5. Analyzing the results, identifying defects. After conducting the pile integrity test, the recorded data is analyzed to evaluate the condition of the pile and identify any potential defects. This analysis involves interpreting the wave patterns generated by the hammer impact and their reflections as they travel through the pile. The recorded data is typically displayed as a graph showing the acceleration of the pile head over time. This graph, known as a force time or velocity time history, provides valuable information about the pile's integrity. A sound and defect-free pile will exhibit a characteristic wave pattern with a clear initial impact response followed by a gradual decay of vibrations. Any deviations from this pattern may indicate the presence of defects. Common defects that can be identified through PIT include cracks, which create reflections of the stress waves, appearing as sharp peaks or dips in the wave pattern. Voids, or large air pockets within the pile, cause a sudden change in the wave impedance, leading to significant reflections and a distorted wave pattern. Changes in cross-section, such as necking or bulging, can also be identified by analyzing the reflections and transmission of stress waves. Interpreting these wave patterns requires experience and expertise. Qualified engineers or technicians skilled in PIT data analysis can accurately identify defects and assess their severity. Section 6. Advantages and disadvantages of PIT. Pile integrity testing offers several advantages as a non-destructive testing method for evaluating foundation piles. However, like any testing method, it also has its limitations. Advantages include being non-destructive, meaning it does not damage the pile during testing, which is crucial for maintaining the integrity of the foundation. It's also cost-effective compared to other methods like core drilling, especially for a large number of piles. PIT is relatively fast and efficient, allowing for the inspection of multiple piles in a shorter time frame. It's versatile and can be used on various pile types, including driven concrete piles, cast-in-place concrete piles, and even timber piles. However, there are limitations. Accurate interpretation of PIT results requires specialized knowledge and experience. While PIT can detect the presence of defects, it may not always provide precise information about the depth or exact location of the defect within the pile. The condition of the pile head surface can affect the test results, and uneven or damaged surfaces may require additional preparation or alternative testing methods. Access limitations, such as overhead obstructions or tight spaces, can pose challenges for conducting PIT. Section 7. Best practices and importance of skilled personnel. To ensure the accuracy and reliability of pile integrity testing, adhering to best practices and engaging skilled personnel is crucial. This includes having qualified professionals conduct the test. PIT should be conducted by qualified and experienced engineers or technicians who are trained in the proper procedures for conducting the test and interpreting the results. Proper calibration of all testing equipment, including the hammer, accelerometer and data acquisition system, should be ensured before and after each test to maintain accuracy. Appropriate testing parameters such as hammer size and impact energy should be carefully selected based on the pile's characteristics and the project specification. Clear documentation of all aspects of the PIT, from the testing procedure to the results and interpretation, should be maintained and archived for future reference. Adhering to relevant industry standards, such as ASTM D5882, provides guidelines and best practices for conducting PIT. By following these best practices, the reliability and accuracy of PIT results can be significantly enhanced, providing valuable information for making informed decisions about the foundation's integrity. Section 8. Conclusion. Ensuring foundation integrity with PIT. Pile integrity testing, or PIT, is an essential tool for evaluating the structural integrity of foundation piles, playing a crucial role in ensuring the safety and longevity of structures. By generating and analyzing stress waves traveling through the pile, PIT can detect defects that might otherwise go unnoticed, preventing potential structural issues and costly repairs in the future. While PIT offers numerous advantages, including being a non-destructive, cost-effective and versatile testing method, it's essential to acknowledge its limitations. Accurate interpretation of PIT results requires specialized knowledge and experience. The testing conditions, such as surface conditions and access limitations, can also influence the results. By adhering to best practices, engaging skilled personnel, and following industry standards, the reliability and accuracy of PTIC can be greatly enhanced. PIT is a valuable tool for engineers and contractors, providing critical information about the condition of foundation piles and contributing to the construction of safe and durable structures.